method of digital learning of engineering softwares through learning portals, virtual internships for engineering students, faculty members, and researchers. He has conducted number of sessions, webinars, and trainings on reality modeling, virtual reality, and augmented reality. So once again, I welcome you, sir. Now the session is over to you, sir.
Okay, just a minute. Just check if my screen is visible.
Yes, sir. Your screen is visible, sir. You are audible.
Thank you so much. Now, good morning to one and all gathered here. I would like to thank the entire management of Ramco Institute of Technology. So just last month, I came to your institution for the inauguration and signing of MOU of the BIM lab in your civil department. Now, I would also like to thank the head of the department, civil engineering, and all the faculties who organized this particular online session on a niche topic called reality modeling for future infrastructures. Now, this is my 114th webinar for 2022. And it's really a great privilege. Again, I'm joining with the student community. Now, I'm not going to take you into too much of technical concepts. I'm just going to give you information on reality modeling for future infrastructures, where I want all the students, if you have a pen and paper, please take a note of all the concepts, important things that I'm sharing with you right now. This is going to be very, very important for you in the forthcoming sessions and for your future career. This is typically a peculiar modeling concept which I'm going to give you information. So I want everyone to be very much attentive, interactive, and please take note of all the details which I'm giving you right now. And also I would like to say that I would appreciate if any of the students who has wanted to do any projects using the reality modeling concepts, we would really appreciate. We will give you the softwares free of cost. And if you are showcasing your projects, then we will post it in our Bentley LinkedIn website. We will post it in our annual magazine, and you will be rewarded as well. So that is the reason I want everyone to concentrate for another 1 hour, just 60 minutes. Whatever the information I'm sharing with you right now. Now you can stop me then and there because I can't see the chat box. You can ask your coordinator if you have any questions in between. You can unmute and you can ask me any questions. Right. So today's topic, what I have chosen is reality modeling for future infrastructures. So for another 1 year, we are going to touch upon a lot of topics, a lot of future technologies pertaining to infrastructure, civil engineering, and structural engineering. We are going to teach a lot of softwares, concepts, projects. Now, why I am starting the sessions, the first session with reality modeling is, this reality modeling is a concept which is now used in any of civil infrastructure projects, which is a latest technology. And in fact, most of the institutions are now starting reality modeling laboratories. So the roadmap, the growth of any civil engineering department will be like this. For all these years, you had something called CAD lab. Now from CAD lab, we have to move on to the BIM labs. And from BIM labs, we have to move on to AR, VR, and RM. AR is nothing but augmented reality. VR is virtual reality. RM is reality modeling. Likewise, the growth of your laboratory and the knowledge of students' talent pipeline should grow. That is the roadmap. Of course, you can add drone surveying, drone mappings, and everything. I'll be giving you all these informations. So I thought giving informations about reality modeling as start of very first session will give you a lot of insights of what are the kinds of projects happening in and around globally in India, in your city using this reality modeling. Okay, I'm just sharing. Is this session recorded, madam? Please record the session.
Yes, sir. We are recording the session, sir.
Okay, just a minute. So today's session topic is reality modeling for infrastructure. Now, let me just brief you what is reality modeling. The reality is nothing but a real world. The word reality is nothing but a real world. And of course, you all know what is modeling. So you do any kind of modeling, you do any kind of 3D modeling, in fact, using your real world images, real world concepts, then it is called as reality modeling. So you bring your real world, your reality data into your infrastructure projects using reality modeling. Real world in the sense whatever you see, the entire earth, whatever you see through your eyes is all reality. Okay, and then if you wanted to bring some kind of an engineering data into that reality modeling, and you wanted to do some kind of a 3D modeling, then it is called as reality modeling. So you use the real world and your engineering data, your digital data, you just combine both and you create a whole new infrastructure, a 3D model, and that is concept is called as reality modeling. Suppose, for example, you have a building in your institute, you wanted to do a 3D model out of it. Suppose your main campus. So main campus is a real world object, and how to do a 3D model out of it if you don't have any kind of engineering data is very simple. Just you take a high resolution camera, or in fact you can use your tab, or you can use your smartphones which is really having high resolution cameras, or if you fly using a drones, the drones fitted with cameras, and you take photographs of that particular building 360-degree, as many number of photographs. But you need a small technical skill over here. It's very simple. It's not an engineering technical skill. You should take photograph in such a way that each and every photograph should snap with each other. So more number of photographs you take in a 360-degree, whatever the real world object, you take photographs and you upload those photographs in the reality modeling software, and you do a aero triangulation, then the output is nothing but the 3D model of that particular real world. Now what we are doing, a real world of that particular building in a digital format. In your laptop or in your computer, you get it in a digital format within minutes, within hours. It's very simple. You don't have to search for 3D drawing, AutoCAD drawings, survey, all these things. Nothing needed. Just take a photograph, images, and you upload it in reality modeling software. You get a 3D model out of it. I'm just giving you point blank briefing about reality modeling so that you can understand easily. Now, you can do, you can create 3D model out of simple photos of real world imageries. And using the reality as context, you can use it for any kind of decision making in very big projects. So you might be thinking, what is that? We get more information. In the coming slides, you will see how important this reality modeling plays a vital role in infrastructure projects. So now for time being, you just remember reality modeling is a process of capturing a physical reality on Earth, or any of the infrastructure asset on earth. It may be a city, it may be a building, it may be a forest, it may be a mines, or whatever it is, and you create a representation of it, and you process it, and you use the existing data with our 3D imaging point cloud software that is called as reality modeling. Now, reality modeling is a concept, and the software which is used for reality modeling is called as context capture. Okay, so just note it down. Now, whatever you see in front of your in reality, in real world, any objects, any physical assets, if you have a digital drawing of that particular physical asset in any of a software format, file format, in your laptop or in your computer, it is called as a digital twins. Okay, suppose you have a car, or a building or any physical, and that is a real world physical asset. The same thing, if you have a 3D model in your laptop or in your computer in a digital format, in a file format, then that is called as a digital twin. So please remember the words and the concepts. Okay, so that is called as a digital twin. In fact, whatever you have in a digital format, in your file, in kind of a file format, is all called as a digital twin. So here afterwards, there will be no paperwork, there will be no paper drawings, everything will be in digital formats. So real world images, real world physical assets in digital format is called as a digital twin. Okay, now how this digital twin is using this reality modeling concept. So as I told you already, reality modeling is a process of capturing existing site conditions using photographs and point clouds to create high georeference 3D models. Now, we take photographs using cameras, laptop, tabs or drones or something like that. So now what is point clouds? The point clouds are nothing but, suppose we fly a drone, and from that drone there are two kinds of surveys now we are doing in aerial mapping. One is nothing but taking photographs using drones and UAVs, unmanned aerial vehicles, or even we sometimes fly an aeroplane and we take photographs, we take videos. Otherwise, we set up a hardware that is called as a scanner, an ultraviolet ray scanner. So that particular scanner will use these ultraviolet rays, and it will send rays, and it will find the distance of the object over the earth. Okay, and using that we create 3D models. So everything will be in point, so that is called as a point cloud. Okay, now for doing smart cities, for preparing maps, atlas maps, and for urban planning, everything now the consultants are using point cloud data. That is simply they fly now. Now the process of total station survey, GPS survey, other things, the usage of those kind of surveys are coming down now. The type of survey widely used for infrastructure planning is nothing but reality modeling, and then point clouds. Point clouds, if you collect a point clouds, that concept is called as lidar data. Okay, so light detections and ranging, so that is called as a lidar data, and that concept is, and the data is called as a point cloud data. In fact, you can upload these photographs in the reality modeling software and create 3D models, or else you can upload this point cloud data also in the reality modeling software and you can create 3D models. But everything is using the real world data. Now, in today's uh, the infrastructure industry, if you see some kind of challenges, why I have listed some kind of challenges is this: reality modeling is playing a vital role in facing all these challenges, in providing solutions for all these challenges. For example, engineering data of a heritage buildings. So we have so many buildings, heritage buildings, temples, forts, which are thousands of years old. We don't have any kind of engineering data. How to create a 3D model out of it? We don't have what data is that, what is the height of that particular thing, and the actual 3D model, we do not have anything. But if you wanted to create a 3D model for any kind of renovations, for any kind of emergency planning, very simple, reality modeling plays a vital role. You can simply fly a drone, you take high resolution photographs, and then you do an aero triangulation using a reality modeling software called context capture. You get an actual 3D model of that heritage building, of any temples or whatever it is. Now, just recently, we just did a pilot project for Madurai Meenakshi Amman temple. Now, complex engineering softwares for 3D model. Suppose if you want to do a 3D model, there are a lot of complex engineering software. 3D modeling softwares are there, which really need a lot of technical knowledge and skill for you to open the software, learn each and every tools. You need to be skillful in understanding the unit systems and other things. Here, it is very simple. You don't have to be too much of technical on drawings, 3D drawings in any kind of softwares. You have to be very much skillful in taking a photographs or using how to use a point cloud data, upload the point cloud data in the reality modeling software. It automatically does the georeferencing, and then you get a 3D model out of it. It's as simple as that. This process is very much time consuming, and reality modeling is nowadays used for any kind of emergency plannings, disaster managements, and then for any kind of transportation assets upgrades and maintenance challenges. Now you can see a lot of two-way lane roads, highways are being upgraded to four-way lanes. So for that, they have to create concepts. For creating concepts and for approval from the stakeholders, you have to create a 3D model before even you start the project. For there, this reality modeling plays a vital role. Now, spatial data infrastructure. So this is a very big concept. There is a policy being now being created by government to have a spatial data infrastructure of the entire country. So a lot of departments are contributing for that. So reality modeling plays a vital role. And if you take any kind of underground infrastructures, for example, underground assets like electrical wiring or even piping, whichever is underground infrastructure management, so for that, reality modeling plays a vital role. And then to maintain an environmental ecosystems, this plays a vital role, because all kind of revamping processes are carried out by creating concepts using RM. Now, any of the digital smart cities creating maps. Now, Chennai is called as a Greater Chennai. For that, they are creating a very big map of Greater Chennai. There, they are using drones and aeroplanes to create, to capture images and collect data and creating 3D models. Any kind of construction challenges can be resolved using this particular technique. Now the software supporting, so then now we are using two kinds of data in reality modeling. One is the photographs, what we are taking using cameras, and then one is using scanners, point clouds. So these two are the source data for reality modeling software. Now with Bentley, we have reality modeling software called Context Capture Center, Context Capture Mobile. In fact, you can also download it from Google Play Store, but this will is can be used only for survey context capture mobile app. Okay, and then Bentley point clouds. Now, highly accurate context from simple photography. Now this is, you may be thinking that how can we bring a highly accurate engineering data included 3D model out of some simple photographs. So that's how this particular concept and the software is developed. So now, for example, before you beginning any infrastructure projects, now a project team needs to do survey of existing conditions in order to provide foundational input for decision making process. So to understand that particular concept context within which asset will be designed, built, and operated. Now, normally conventional, traditionally hardwares and softwares used are nothing but total stations, ground-based laser scanners, and sometimes they are using satellite imageries. Like for example, we can buy a satellite imagery for minimum 25 square kilometer from NRSE. NRSE is nothing but a government department called National Remote Sensing Center. In India, we can buy satellite imageries only from NRSE. But apart from India, you can directly buy from satellite imageries providing companies. So satellite images are nothing but So some satellite will take a picture of whatever the area you require. Suppose your college is 25 square kilometer minimum and you wanted to have today's photographs, satellite imagery, which may be a 5 centimeter resolution. You can order the satellite to fly over that particular area and capture that image. But that image you have to pay and you have to buy from NRSE. So that image also used nowadays for creating larger maps for smart cities, and that is a very vital data. In fact, you can buy kind of survey maps from Survey of India. You can use GPS to collect data. You can use point cloud data. Now, aerial mapping. Aerial mapping is nothing but you fly an aeroplane and you collect data of the ground reality. Is called aerial mapping. But Bentley, however, has introduced a new technology that takes the data capture out of hands of specialists. So if you see all these things, total station from 1 to 7, you have to be very much specialist on that particular technology. Total station, you have to be very good on that. How to, you should know how to use the particular hardware. Now, what Bentley has done, even if you're not a specialist, you can simply create 3D model out of simple photographs. So that is what this particular slide reflects. Now you should understand the concept called reality mesh model. So you just understand all these concepts: reality model, 3D model out of simple photographs. Digital twin is nothing but if you have any real world assets, physical assets in a digital format, in a file format, is called digital twin. And reality mesh. Now, what is a reality mesh? I told you that if you take photographs and you upload it in your reality modeling software, you will do an arrow triangulations. The software automatically process all the photographs and it will create a file called 3mx. That file format is nothing but .3mx. How your AutoCAD file format or .dwg. Likewise, this particular software's file format is .3mx extension. Okay, here what the software does is actually is doing a reality mesh using all these photographs, and it also does georeferencing. Okay, now reality mesh models consist of many files that are assessed as needed during the display process. And the scene file with extension .3mx, it contains information about the model, including its geographic location, which geographic location you have taken photograph. I'm sorry. So those processes are done inside the context capture software. That process is called as reality mesh. So you might be thinking this as a satellite image. No, this is an output of a context capture model. Now, practically, this particular software is used in various infrastructure projects. Let's see all those things in the coming slides. But for now, you need to understand the concepts. Now, I think I have given you enough of information about RM, reality modeling. Now, it is very vital that as a student, you have to know the concepts of AR, VR, and MR. AR is nothing but augmented reality, VR is nothing but virtual reality, and MR is mixed reality. Now, virtual reality, VR, virtual means what? There is nothing available. It is a digitally created world. There is nothing like that in real world. Okay, that is called as virtual reality. It is a fully immersive, which tricks your senses into thinking you're in a different environment or world apart from the real world. So sometimes, if you can see some kind of video games are there, you have to use a head mounted display, HMD, or Google lenses, so where you can play VR games. So that is called as virtual reality. But what VR does for infrastructure civil engineering, we'll see it in the coming slides. Now, virtual reality is nothing but a reality, but which is actually not available, where it is being created virtually. Now, what is augmented reality? Augmented reality is nothing but you bring some kind of a digital format into the real world. So for example, you might have heard about games like Pokemon Go, and all these things are called as augmented reality. In this picture, if you can see, even if you can download a lot of AR, augmented reality apps from your Google Play Store, where suppose if you wanted to bring any kind of digital content like any drawings, any civil engineering drawings, but if you see in left side that in photographs a person is walking, he is having that AR app and he is walking in a pavement and he wanted to bring some kind of a doll. He's bringing that as though he's walking, and that also is walking in that real world. This is called as augmented reality. How this AR is useful for infrastructure industry? Very much it is useful. Now I want everyone to just see this video of how AR is playing a role in infrastructure projects. So that's AR applications used for construction projects. Now, what is MR? MR is nothing but a mixed reality. It actually has real world as well as VR. So if you combine both AR and VR, then it is called as a mixed reality. It's an integration of real and virtual worlds to produce new visualizations. For example, you might have seen a lot of news channels which are using MR for various visualization process.
The 2020 Atlantic hurricane season is underway.
Well, the chance of storms does not end today. We'll be watching severe weather again tomorrow. You could be dealing with a ton of tropical moisture.
What wind and water could some of you be experiencing?
We've got the showers and thunderstorms overnight and into the day Wednesday.
A number of wind and especially water impacts.
How about a weather forecast? Out here at the drive-in movie theater, we're going to bring up here our big screen.
A system this big is not just going to go away.
So that is mixed reality, mixing your virtual reality, virtual and real world for a better visualization. So this is also been widely used in construction projects. So how now we have to combine reality modeling, VR, AR and MRs, how it is practically used in different infrastructure projects. Now here, if you see for mining, in the left side picture, you can see a existing topography from USGS. Okay, topography is nothing but USGS is nothing but United States Geographical Survey, which provides topography of the entire world. This is a mining site, and you can see proposed grading design using USGS topography. Whereas if we are using same topography using a context capture reality modeling, you can see the clarity and the level of informations. It gives proposed grading design using context capture topography. You can see the clarity. Okay, you can see the color differences. The people in the geotechnical and mining will know the effect and the difference of this color combinations. Just a minute. Okay. Now this is actually a model which is created from context capture using reality modeling for a highway project in Scotland, and for creating a smart city. So this is in Europe. Now we have to touch upon a lot of things on BIM. So building information modeling. So BIM is the next biggest concept in the infrastructure industry. But let's see that how this reality modeling, what we are talking about, is very good at site planning. So this is one of our projects, a winning project. So every year we conduct competitions for companies using Bentley's technologies globally. So this is one of a winning project. It is actually a construction of supermarket. So your design starts with understanding the client's business needs. So here they are going to construct a supermarket. Then you will do calculate space needs, organization demands, and you explore building forms. Then you go for site selection, site planning. Here we are using reality model from photos of the site. They have chosen this particular site, and 3D model is created using RM techniques. Then the site optimization. So you can create any kind of walkthroughs, you can have stunning visualizations. It's a combination of all Bentley products. See, we have used context capture for site planning, site ops for computational design. We have used BIM software EcoSim Building Designer for walkthroughs, Luminarity. For this entire project, they have used 5 different technologies from Bentley. Now let's see that how a 3D reality mesh of this particular project. So you create 3D reality mesh from a simple photograph.
Context Capture is Bentley's reality modeling solution that can quickly produce 3D engineering-ready reality meshes using simple photos and/or point clouds to provide real-world context for all types of infrastructure projects throughout the world. Fully scalable and versatile, Context Capture can be applied to many types of assets at different scales and uses a variety of sensors, from laser scanners to handheld cameras or smartphones, to produce precise reality meshes affordably with less investment of time and resources. You can combine aerial and ground-based photos to produce an accurate 3D model of your assets, whether it be an industrial site or an entire city. Using simple photos, Context Capture employs automatic area triangulation, 3D reconstruction, texture mapping, and reconstruction constraints to generate highly detailed 3D reality meshes, point clouds, and orthophotos. Add LiDAR to your photo acquisition when the surface select texture or the acquisition constraints do not allow for close capture of your target. Leveraging point clouds results in fine details, sharp edges, and geometric accuracy, even when far from your target, such as this substation. Depending on your reality modeling workflow, Context Capture is available as an on-premise or cloud processing service solution. You can produce 3D reality meshes on your local machine or upgrade the Context Capture Center to save time by employing scalable computing power to speed production of your 3D models, leveraging the latest parallel computing systems. Using a desktop or mobile application, take advantage of Context Capture cloud processing to generate 3D models without high-end hardware requirements or IT constraints. Context Capture ensures interoperability, allowing project teams to easily and consistently publish and share reality modeling information, consumable and accessible, on desktop and mobile devices in many formats, including native use within MicroStation for use in any engineering or GIS workflow. Leveraging project-wise context share, a connected data environment, you can quickly and securely manage, search, download and stream reality meshes and their input sources across project teams and applications. And with a Navigator web application, you can get high-performance streaming of very large reality meshes through the browser to your desktop or mobile devices. With your 3D model, you can accurately measure coordinates, distances, areas, and volumes. Context Capture offers a full reality modeling workflow, from acquisition planning through to consumption of your reality mesh in design, construction, operations, and inspection. In design, reality meshes can be used to better understand existing conditions, to help manage the risk of constructability issues and identify potential issues earlier. In construction, reality meshes can be used for continuous surveying and monitoring of construction sites, for change management and documentation. In operations, reality meshes can be used to train new staff on existing assets and operating conditions. These same 3D models can be used for visual operation, allowing owner-operators to easily document existing conditions of industrial sites or factories. The 3D model can be linked to AssetWise or other asset management systems to navigate the reality mesh virtually and to query the database database quickly to find a specific asset. Reality meshes can help speed the inspection process and offer higher quality, more repeatable documentation. Additionally, reality modeling techniques allow for easier access to hard-to-inspect locations. Context capture is the reality modeling solution for creating and sharing highly detailed 3D engineering-ready reality meshes to provide precise real-world context that can be applied to all phases of an asset lifecycle.
Now let me just show you how our context capture, the reality modeling software actually works in a step-by-step operations. The first thing is simple, like any softwares. Like we create a new project, we import the photos, that we take photos from high resolution cameras, UAVs, or whatever it is. And second thing is we perform a aero triangulation, and then if we have a point cloud data, then we import it. Okay, so here you go to new project, import all your photos. You see I'm just importing all the photos. The photos are loaded with precise positions. Photos can also be added using add photos button, and block can be referenced against the LiDAR data using ground control points. Here you can see the 3D view of the photos I have. These are the areas, these are the locations from where I have taken photos. And then I'm doing an aero triangulation. Aero triangulation is actually, automatic georeferencing and 3D mesh creation. Now go to 3D view. Yeah, you can see kind of photographs and point clouds. Now I'm just uploading. I have a point cloud as well as photographs. I'm uploading a point cloud data. Point cloud data is nothing but data captured using scanner devices set up on aeroplanes or any aerial mapping devices. Now then point cloud data will be processed. Press OK to import your point cloud. And then you can even set the color mode to either texture the 3D mesh, whatever the RGB information you have, and you can review the different scans that compose your thing. And then 3D view. Now you can, anytime you can see the 3D view of the imported scenes. You see this is house that we have captured over a mountain, and the yellow dots represent the location. Then you go to the general tab, you would create a new reconstruction. So in the spatial framework tab, set the tiling if needed, adjust your bounding box, that is your area of interest, because photographs means it takes larger area cover, so you can reduce it to your area of interest. Like this, you can reduce it. And then you name whatever the output for your production. Go to next. You can choose the output format options. Now you again go to 3D view to review your production results. This is how we get the 3D model of a physical asset. This is actually a digital twin of a physical asset. We have not done anything, we have simply taken photographs. and a 360 degree, and we have done a 3D mesh. And this output can be used for any kind of as an input for road projects, for as an input for reconstruction, construction planning, and decision making. Now let me just show you how an emergency planning project has been done using a reality modeling. So the Pope, the John Paul is visiting Philadelphia. So the department wanted to locate a site and plan. It's called as an emergency planning.
To capture a 3D every engineer of infrastructure from scratch in such a short time frame.
So they wanted to fly and capture photographs.
Bentley's Context Capture is an amazing piece of software. For this particular project, we're capturing about a detailed square mile. Most of the photography we're capturing is going to be from the helicopter, but of course there's only so close we can get to the objects, the buildings, the important structures. So what we're also supplementing all this aerial photography with is going to be some ground-based photography. So that involves getting very close to the buildings and reconstructing 3D models of that from ground level imagery, which will add great fidelity and detail.
Photographs taken and reality model has been created. This is actually the reality model. When they planned for the
Well-Being of Families 2015 was the first time that this event has ever been held in the United States. In fact, it was the whole purpose of the Pope's apostolic journey to the United States. So this is a very large-scale event. And what we typically have done in the past is we will utilize 2D CAD drawings and do lots and lots of site surveys. But the ability to leverage this 3D reality modeling was absolutely a game changer for us.
A really important thing was it had to integrate seamlessly for facilities directly in the model without having to go through a lot of translations and import, exports. We just wanted to work seamlessly with the reality model. And that also, with the integration work that Ray Bentley and his team did, it did work seamlessly.
The amazing thing to me was when you capture these models, it captures the GPS coordinates, so we know exactly where on Earth the models are located. I could tell you 5 years ago, if someone told me this was possible to produce a model, I'm still having a hard time believing it works as well as it does now. Prior to this technology, surveying was something done by specialists once. And now I think where we are, this convergence, feel like the Internet of Things, where things are connected together. They can be connected together now in the context of a 3D model captured with reality modeling as it evolves, is constructed, and operated. And a special event was a chance to compress that timeline and experiment and learn together about this new potential.
The fact that we test drove it on a 60-acre site just gives us all the confidence in the world that the next arena, Opera House, Convention Center, or 60-acre site that we choose to employ this tool will be successful again and again. And this will be a tool that we use many, many times into the future.
Congratulations.
So that's how the event was planned. The back-end work for planning includes reality modeling. So many of them that doesn't know that these kind of concepts are used. Now you just create a 3D model out of simple photographs and point cloud data, and then you can actually create a physical 3D model. Is as simple as that. If you really wanted to create any 3D model of a physical asset, you can create it in a digital twin format using reality modeling software, and then that output you give an input to your 3D printer, you get actually a 3D physical output. You just check this video. So we are taking photographs of a person 360 degree. We just create it. We want to create a 3D physical model. The input has been given to the 3D printer. So this is how you can actually create a reality physical asset to a digital twin, and then the digital twin to a physical asset. So this is how the process it. Now, so that is the reality modeling software is a desktop software. You can install it in your desktop, and you can capture the data is nothing but the photographs. You can capture it in whatever the devices you want. Suppose you can also wanted to do kind of a survey in your construction projects. You can download something called Context Capture Mobile, which is available in the Google Play Store. You see the features of Context Capture Mobile. So it is just an application. You can use it in your smartphone, in any of your Android phones. You just go create a new project, like for example inspection. And then you just go, this is the place, and you just take a photograph, click add photo, and start capturing photos around your asset, as many as photographs you can take. So measure a reference distance to set up a scale of your model. See, these are the photographs, and a survey point is also added. And then you can also add an endpoint of your reference distance. Yeah. So that is your first point. In at least 2 images, that first point should be there. And you can also add a second point. See that you repeat the operation. So survey first point, survey point 2 is added. Enter the start and end point and enter a measured distance. Done. So edit processing options if needed and submit. So photos are being uploaded. This is basically a cloud processing process. You can view the results. Review your 3D model when processed. This is a reality data web viewer, not a desktop software. You can see a basic 3D model of that particular asset. So this is again in using cloud. You can use it in your desktop software. You can upload it here itself, so wherein your stakeholder or your engineer sitting in the office will actually view it using the reality data web viewer. So they see from sitting in a different place itself, they can actually review wherever there is a damages, and they can plan, and you can estimate what would be the cost. So all these things is done using Context Capture Mobile. So let me just take you to different applications again. This is for creating large-scale virtual 3D city models. You don't have to be a specialist in surveying and other things. Places where often you go for inspection is difficult, then taking photographs is the best option. For example, you can see for mining and construction sites, see how VR is simulated. Use it for flood management projects, and then different site plannings, new assets constructions, in fact you can calculate solar radiation exposures. This is an abandoned plant where they wanted to decommission it, and they wanted to calculate the bill of materials. You can see this is a wireframed 3D mesh created. Then it can be processed using MicroStation software. So for decommissioning of the plant, again reality modeling is used. Let me just take you fast. So for inspection processes, you can actually create a digitized model. This you have already seen, uploading point clouds. So that's it. I think I have given you enough of informations on all these concepts. Now, actually, our program is nothing but to set up a virtual reality labs with drones, create programs with industry syllabus, then train the students, in these technologies, execute live projects, and provide Bentley certifications. So that is anyway. Those details are there in our programs. So now I'm just open for any questions. We can use it. There are a lot of applications. You can use it for drone surveying. Lot of things which I can show you, but I don't want to give you a lot of technical concepts. So that for time being, it is enough that you understand what is reality modeling and what are the areas, what are the infrastructure projects, and what are the challenges, how it can be used. I think that I have given you enough of information. Now I'm ready. If you have any questions, please ask me some questions.
Sir, one student has one question.
Yes.
Can you explain about the sketch work in the augmented reality?
Voice is not audible. Type it in.
Yes, sir. Can you explain about the sketch work in the augmented reality?
No, I'm not able to hear you. Can you type it in the chat box? Are you asking me about augmented reality? Your voice is echoing.
The question is posted in chat box.
See, augmented reality. I'm just giving you information on virtual reality, augmented reality, mixed reality, and reality modeling. Okay. So if you wanted to go in depth on augmented reality, then I need to have another 2 to 3 hours to explain you on augmented reality for infrastructure. Now, augmented reality is a very big domain. What we have to concentrate is on augmented reality for infrastructure, for civil engineering and structural engineering, how it is used for projects. Now we have augmented reality applications for with Bentley systems. If you just install those augmented reality applications in your mobile, in your tab, or whatever the hardwares you have, and if you have the digital twin of your project, suppose it is a construction project, and you have the digital format, digital drawings, all CAD drawings, 3D drawings in a cloud format, you can view your actual physical asset. You can walk through and you can bring in those engineering drawings which is been designed in your office or somewhere, but you are now in your construction site. And if you have that AR applications, you can merge your real world construction site with your digital drawings, and you can see, is there any class deductions? You can see where the transformer has to come in, where the pump has to come in, where the pipe has to go, where the all those MEP designs has to be designed. So everything you will have a clear picture. So you merge your real world construction site with your digital drawings. This is where AR app is used in construction industries. I think you got it.
So thank you, sir.
Any other questions? Students, you can also try of some projects. You can use your camera, you can use your smartphones, you can just simply take whatever the physical asset you want. You can take photographs, and you can install context capture software in your laptop. You can try it out and you can send me those details. If something some students are doing projects, then we would appreciate. I don't know which year students you are. I can show you a lot of students have won. Every year we conduct students design competitions. You can use any Bentley technology, any software. If your project is exemplary, then you will be awarded, you will be certified from Bentley systems. Now, for example, let me just show you whether I have it.
So one more question in chat box.
Can we get 3D picture of person in context capture? It is not a 3D picture. If you want, that is what I showed you. You have to take photograph of that particular person in 360 degree. You have to make sure that each and every photo snap with each other, and you upload that photograph in a reality modeling software. You get a 3D model out of it. 3D model of that particular person.
Thank you, sir. So no more questions, sir. Shall we move on to formal vote of thanks, sir?
Yes.
Okay, now I invite Mr. V. Raghavan, Assistant Professor, Department of Civil Engineering, to propose vote of thanks.
I feel honored to propose a vote of thanks to everyone present here. On behalf of Department of Civil Engineering and ICA Student Chapter, I extend my heartfelt thanks to our chief guest, Mr.S.Rajesh Kumar, Director Technical Services, TechApps Consulting, Chennai, who spared his valuable time with us in this virtual webinar on reality modeling. Your inputs regarding reality modeling to our students was very informative and useful. We thank you once again for the time and the effort you spent for us. I extend my sincere thanks to our HOD, principal, and the vice principal for their untiring efforts. Finally, a big thanks to all the students of Civil Department. We hope you benefited from today's webinar. I wish you all success to your future. Once again, I thank you all.
Thank you so much. Thanks for organizing this seminar. Thank you so much. Any questions, you can take my email ID from your head of the department. You can send emails to me for any queries. Thank you so much.
Thank you, sir.